for tonight's Public Health and Safety Committee meeting. This was not advertised for a public hearing, so if you have any questions following the meeting, I encourage you to stick around and ask folks for answers. With that said, it is now 6 o'clock, so I will call the meeting to order. Melody, would you please call the roll?
Councilman Holtz.
Present.
Councilman Curry.
Here.
Councilwoman King. Councilman Mishler.
Present.
Councilman Fish. Councilman Holt. Councilwoman Hines. Can't read my own writing. Councilman Crabtree.
Here.
Councilman Hinkie. President Dawson.
All right. With that said, I believe we have a presentation of the Unified Development Ordinance UDO language. Mike, what do you got?
Good evening, Council. Appreciate your flexibility and your time in coming out and joining us as we have this work session tonight. As you all probably know, the city is kind of getting towards the end of creating updates to our UDO and our zoning ordinance. As a part of that, we want to make sure that we're diligent in all different areas and all different aspects. We're also working with the University of Notre Dame, updating some of our housing code language, as was recommended in the Benham Neighborhood Plan and the Downtown Master Plan through an overlay. But one of the things we try to be cognizant of or understand and recognize is when we have emerging technologies that could potentially be new, that haven't been addressed in previous ordinances. We want to make sure we're incorporating and looking into the future to try to find ways to regulate those things, even if we don't have any current projects related to those right now, or haven't previously. And one of those emerging technologies relates to kind of the growth that we're seeing regionally with renewable energy. As you all are aware, we've seen multiple regional data center projects, and all of the development in the region continues to put increased demands on our power supplies. And in conjunction with regional data centers, we're seeing and hearing about projects related to renewable energy projects like solar or wind farms or battery storage projects. So that's one of those emerging trends we're seeing. Particularly, I want to talk a little bit this evening about battery storage. Oftentimes, you'll see battery storage projects kind of in conjunction with renewable solar or wind kind of projects, but there are also opportunities for battery storage projects to be developed as standalone projects as well. And so our intention this evening really is to kind of make sure that you guys have an awareness of kind of the existing conditions and the current state of our power grid and of development trends in the area, in the region. We also wanted to bring some subject matters experts in these fields related to specifically battery energy storage systems this evening. We want them to give you guys an overview and really inform you on the different technologies, what some of the community benefits are, and what are some of the potential concerns that go along with these kinds of projects. And then lastly, we want to provide you with an overview of the language that we're proposing to include in our new UDO zoning ordinance as we look at how we might regulate future developments as they might come, both before the Plan Commission and or the council in the future. So that's really what we're trying to accomplish tonight. Speakers on the agenda this evening will include Chris Stager of the EDC of Elkhart County. We have Becca Gillespie from the Battery Innovation Center and Eric Wood from Energy Response Group. And then lastly, we'll have Eric Trotter of the city zoning team and Cynthia Bowen, who is our lead consultant with Rundle Ernstberger Associates on the zoning ordinance. And I believe we have Fire Chief in attendance as well. So with that, I want to just introduce Chris Stager from the EDC, allow him to kind of just give you a little bit of a current kind of state of the grid analysis.
Thank you, Mike. Good evening, Council.
Good evening.
Oh, lost the windscreen here. A lot of air going through here. So good.
Yep. Could you please state your name for the record?
Oh, my name is Chris Steger, Economic Development Corporation, 300 Nipco Parkway. It's okay. Thank you, Mike. Is that it? Okay. So I thought I'd just kind of give you a little overview of where we're at in Elkhart County with grid and power utilization in relation to our industrial growth. I put the picture of the rotary dial phone up there for very simple fact is we're operating on a power grid that was designed and utilized around the same time as a rotary phone. So we've got a 70-year-old grid that has served us well, but is under duress for a number of reasons. Whether you want to take into industrial growth, changing in federal policy, that sort of thing. But as of right now, about 70% of our grid is over 25 years old. So it's not performing at the levels we need. It's not dynamic, so it can't change based on the utilization that's out there. And it's important that we understand in the context of all the technology development that's going on, that it has to undergo a significant upgrade, and additional inputs into that are really important. Under the Biden administration, you probably heard that coal-fired generation was a no-no. So we saw we saw the accelerated closure of numerous coal-fired facilities in the state of Indiana. So when we get around to talking about what that did for our utility providers, it really lowered the level of what we call base generation. Okay, base generation is what we need at all times to make sure that everything is maintained and operating as it should. We went into sustainable forms of energy, wind, solar. So what we're seeing now is, at any given time, we have X amount of base generation as needed. That solar and battery supplements that. In most cases, it's adequate for the time being, but the projected usage by both the PJM grid and the MISO grid is significant. It's about 58% growth between now and 2030 is the most recent statistic. If you're not familiar with the grids, figure County Road 17 to the east is the MISO grid, and to the west is the PJM grid. So we are served by two grids. All of the utility providers pay a not-for-profit called the North American Reliability Corporation to compile data on energy and what's going on in the national grid. I thought I'd include this slide because it's really, telling. Everything in orange says we have a potential, a risk potential between now and 2028 of having brownouts or intermittent service. There are a variety of other things that could occur. So this is the national entity that keeps this information on behalf of the power utilities. So that's not a real favorable situation. Given in our industrial base, we're definitely more impacted when we have issues. Next slide, Mike. Indiana, in its policy for economic growth, we have an ideal situation for hyperscaler growth. If you don't know it, a lot of the trunking fiber from the East Coast goes right across northern Indiana. We have robust power. We have very good water. So we are an ideal location for data center development. And you're obviously seeing that occurring all along the corridor with the Microsoft Center that is slated for Capitol Avenue, the Amazon Center that's being built in New Carlisle, and then additional facilities going west. We'll have the lion's share of data centers here. I've been told that the Amazon investment when it's all said and done, in Indiana will exceed what it is in Northern Virginia relative to their data assets. So that's a significant amount invested. They have something like 22 data centers in the state of Virginia. So it's really important that we, keep forward thinking relative to power. I can tell you that in July of this year, on the southeast side of Elkhart, we had 17 businesses lose power on a Monday, about 10 o'clock in the morning, didn't get it back that day. Ultimately, that's grid reliability. Ultimately, it was a $30,000 part that didn't have on hand. But 70-year-old, think of it, trying to fix something that's 70 years old. You don't got parts laying around. You can't easily get them manufactured. So we have a sort of a perfect storm of events that happened there. One business alone calculated their loss in excess of $500,000 for that particular event, and there were 15 of them. So the economic impact of that is sizable. I can tell you 3 or 4 years ago, Napanee, we had some issues as well. We had brownouts, roaming brownouts. We met with, and NIPSCO was very responsive. I'll give them credit. They made some corrective action, but given the amount of use that we have, we're definitely very challenged. Next slide, please. Ultimately, we've all heard about small-scale nuclear, and that's probably a solution that we'll end up experiencing before. But the battery storage technology is not new. It's been around for a while. It's kind of like a Tesla self-driving automobile. You only hear about the bad stuff and you don't hear about the good stuff. But it is a proven technology that's been utilized a lot in the industry. And we have some professionals here today. I think they'll take you through the technology and you'll understand it a lot better. Under the proper circumstances, well managed, it can be a very, very viable source of supplemental base power. And I'd like you just to take a look at it and try to understand it a little bit better. But our community, has always been forward thinking. We're now about 2 months away from turning on the solar facility in the south part of the county. It's a 100 megawatt solar facility. It'll be providing 100 megawatts. That power has been sold to I&M. So, and ultimately they serve in the PJM grid. So that will supplement the existing power that we have locally and make our industrial clients, I guess we'll see a better quality power. We also are seeing as a result of the grid being a long time, very old, we're starting to see companies that have degradation in equipment because of over voltage and under voltage. And this technology that we're talking about here does kind of smooth all that out and makes the power delivery and the power frequency a little bit smoother. So with that, that's really all I had to say, Mike. Just want to let you know that we support battery technologies and hopefully down the road we'll have a viable project for you. So thank you.
Hi, thanks for having us. I'm Becca Gillespie from the Battery Innovation Center, and I'm joined with Les Alexander, also from the Battery Innovation Center, and we're going to be talking about sort of a basic overview of what are battery energy storage systems. You can go to the next slide. What are battery energy storage systems? What is the chemistry behind them? And Les will speak directly to that, and I'll talk a little bit about the electrical side of what they do. Then we'll talk about what a typical battery energy storage project development might look like from your seat here in City Council, what they might be doing, how best operations might look once they get started, and then some of the benefits and some of the risks associated with the technology. You can go to the next slide. I guess as John stated to some degree already, the battery energy storage systems are basically at the highest level. They are there to help store the energy that maybe a renewable generator produced when it wasn't needed and use it for a later time. They help provide that peaking capacity to the grid for those moments when, it's the hottest summer day in July and everyone turns on their air conditioning. They can provide that peaking capacity to the grid And they can also help stabilize the grid and provide frequency regulation. And even if they're operated by a utility, some of the really, really high frequency stabilization that can keep the grid solid and at a constant voltage. You can go to the next slide. There we go. At a really high level, just what is a battery energy storage made up of? So battery energy storage systems, believe it or not, these huge batteries that connect to our electric grid are made of hundreds of thousands of cells connected together in series and in parallel and put together to add up to the voltage that we need to get to the grid. Each of these, this would be the inside of what a typical module might look like, a battery energy storage module. And it contains cells, all the cells packed together to make a pack. The packs might be stacked together into making a rack. The racks will be connected together, probably even continue to be connected together in parallel to build up that voltage even higher into making a big DC module. And then each of these DC modules typically contains its own heating and cooling system, or at least it has its own sensors and controls. It might be that they're sharing a heating and cooling system with various DC modules, but that they each have their own controls. They each have their own fire protection system. And then from the fire safety perspective, they tend to each be modular and self-contained and there could never be an event that spreads from one to the next. So each of these small modules is in of itself a battery energy storage system. Then you can string a whole bunch of those together and you connect them to something called a PCS. And if you've ever worked with or heard of a solar project, you've maybe heard the word inverter. So inverters, when you connect a whole bunch of solar power together, solar panels together, you connect them to an inverter that turns your DC power into your AC power. A PCS is that, except it also converts AC back to DC because sometimes you're charging the battery. So it's just a fancy word for an inverter. Some people even call the PCS a two-way inverter. Some people call them some people just call them inverters, frankly, because they don't know. No, just kidding. But some people just call them inverters, but really they're PCSs because they go both ways. So inverter / converter. Converter is the word from AC to DC. At a really high level, what are some of the words and terms you'll hear when you start getting a battery energy storage project across your desk? The core specifications are the power of the battery energy storage system. That's the total power output of all of those strings, all of those PCSs connected together in parallel, and the energy. So the energy is just simply how long you can discharge at that power. So you might have, you see this example of this little time versus power graph here. You might have a 10 megawatt 4-hour system, and that would be simply a 40 megawatt hour battery. So just multiply power times duration to get energy. This might seem really didactic. Might think you don't need to know this, and maybe you don't, but you actually will see in press releases, people switch between power and energy. Sometimes they don't always know what they mean, or they don't understand the difference. So I guess my sort of battery 101 point of view is this, don't let that hour slip by your eyes, because they are different. And in fact, almost all battery energy storage systems being deployed in PJM right now, which is your grid, and in MISO, frankly, which is next door, are 4-hour batteries. So they're almost always a factor of 4 different. So it is kind of a bit confusing when people mess up which one's which. So anyway, that's kind of important. You can just flip to the next quickly. In case you were wondering, some people wonder this, can you discharge that 40 megawatt hour battery at 5 megawatts for 8 hours? Yes, you can. No surprise there. And then go to the next slide. And can you discharge it in any old weird shape to meet whatever the heck weird thing is going on your grid? You certainly can. Just the area under that curve has to be 40 megawatt hours. So a little geek out moment there. I think I will switch to Les, and he'll tell you a little bit more about battery energy technologies in general, and then particularly lithium ion chemistries, because those are the most popular.
Good evening. Thank you, Becca. So I'm Les Alexander. I'm the CEO of the Battery Innovation Center. Just for information purposes, we're a nonprofit down southern Indiana by the Crane Naval Base. Been around about 13 years. We served about 500 customers. helping them develop battery technologies, mainly in the chemistry area, but we do testing and evaluation of products for the OEMs, and we also do education and training. So that's a little bit of background organization. We're a 20-person organization, chemists, chemical engineers, and lots of electrical engineers around testing. So we're homegrown in Indiana here. I've been CEO the last 2 years. So just talking about chemistries, no two lithium-ion chemistries are the same. So we'll talk a little bit about chemistries. So when you look at different types of energy storage systems, you could have pumped hydro systems that would give you energy storage. Lithium batteries are the most common energy storage technologies that are out there. Flow batteries, people are developing flow batteries. There are some flow batteries on the grid, but it's not a very common system that we have. Then they're looking at thermal and air systems for energy storage. And then there's other different chemistries that are coming online. So people are researching and developing new energy storage systems all the time, but lithium ion is the most common, right? Next slide. So when you look at lithium ions, as I said, they're most favored, mainly because of cost. And there's lots of these types of systems globally around the world. So people have been working on this for quite a while. A lot of these systems are still on the grid. I was with a company 10, 15 years ago. They put grid systems out there looking at wind and solar. Those systems are still operating today. Next slide. So different types of lithium chemistries. So what actually goes inside the cell? People have developed different kinds of chemistries. You've heard lots of types of systems coming back from China. Most of these chemistries were founded and discovered in the United States. They were commercialized in China, and now they're being sold back into the United States. So when they were developed at our national labs, at our universities, at our small companies, they had no place to commercialize them. That technology went overseas. It was commercialized and invested in China and brought back to the United States. So lithium iron phosphate is the most prominent because it's the most safe. That's kind of out on the market right now, and it's one of the most produced. China is making quite a bit of these types of cells, so it's excellent for grid applications. Other chemistries, NMC, lots of your cars, if you have electric vehicles, they're using an NMC because it has a higher energy density, but it's not quite as safe, and it's a little bit more expensive than you would have in your iron phosphate. Other chemistries, you have your NCAs. Most of those are mainly in your electronics. A lot of your laptops and your cell phones are in the NCA family. And then LTO, a long-range chemistry, lots of cycle life, but it doesn't have the power that you need for the grid. So those are the types of chemistries. Lithium sulfur is a very new chemistry, very high energy density, not as much power, but it doesn't have the cycle life. It doesn't run as long as you would need for the grid. So that's a chemistry that's still being developed. Next slide. So when you look at these chemistries, you can see how they kind of stack out and what their positive and negatives of having those and what types of companies and applications. So your iron phosphate, they're in vehicles on the grid. Your NCA is mainly in vehicles, some on the grid, but not as much. Your LCO, it's a low power operation, so it's not something suitable for the grid. You go through your LTO all the way down to your lithium sulfur. These are other chemistries that are being developed, all in the lithium iron family, but it's not as accessible as the LFP, the lithium iron phosphate. So mainly people that are putting grid systems out there are using the LFP chemistry. So as I've said before, I'll just wrap up here. Lithium iron phosphate is probably the most prominent with the NMC coming in a second. They're starting to look at sodium. Sodium is a new chemistry that's being developed. It could have pretty impactful grid applications, but it's probably 2 or 3 years away. So that's not something that I would take a risk at in bringing that chemistry online. Any questions? Right,
Councilman Henke.
So as new technologies come along,
yes, sir.
Is it possible to convert then to the new technology? For example, sodium, and exchange that for lithium?
Yep. So it is possible. However, there's a couple of things that would have to happen. So in your cabinet, the cabinet that Becca showed, that structural system, the way that they built out the drawers, the racks in there, it fits a certain cell size. So if you made the cell size consistent with what the old cell size is, you could fit in the new cells and they have the same connection points. A little bit difficult and challenging. The second thing that you have to do is that each chemistry has its own software. So you have to redo the software to make sure that it's addressing the chemistry. The software in your battery management system, believe it or not, is to control the chemistry. It's to track the temperature and how that chemistry is performing inside that cell. And if the chemistry is performing poorly, it will shut that drawer down. So you can change out that rack. So it is possible to switch out that, but you have to have some consistency of the form factor of your cell and actually update the electrical.
And it could be cost prohibitive unless it's that efficient.
Absolutely, absolutely. But these systems, when I was at A123, the automotive requirements was 80% left of capacity in 10 years. So meaning that if your vehicle was 10 years old, it still had to have 80% capacity of your battery. So that was the standard. In the grid, it was 20 years at 80%. The cycle life and the way that people are using the systems is proven that they're going to last longer than 20 years. Because we didn't have the data, we didn't have the real world data of how these systems are being deployed. And it's all the temperature dependent. So if you had a system in Alaska, it's going to perform much differently than a system in Miami because of the heat and everything else.
Thank you.
Mm-hmm.
Thank you. Speaking of life expectancies, we have had situations here in Elkhart and around the country when it comes to gas stations, for example, where they close and then the city is left on the hook cleaning the site, essentially. What is an expected lifetime for one of these facilities, and what are the costs of closing them and the environmental risks there?
So the environmental risk is probably in a couple different areas. If you have an event, meaning that you had a battery failure that caused a spill or something of that nature, it's a possibility that you would have to have some kind of, excavation of the soil or everything where you would have some electrolytes spill into. Most of these systems now are in self-contained units. So if a spill is contained in that, unless you had a serious event like a fire and you had to douse it with water and you had some spillage there, you would have to have some cleanup. Most of these batteries now are, I won't say 100% recyclable, but they're up to over 90% recyclable. So those batteries would be taken away and they would be recycled. There's enough recycling facilities. The United States have invested in enough recycling that those batteries could be recycled.
Okay. And what about the expected lifespan of a facility?
So I think everything is based on your use case. So your engineers and everything would have to figure out what your use case is, and they would size the system for a minimum of a 20-year life. But as I say, you depending on how you use, looks like they can last more than actually 20 years because the batteries are outperforming what they were originally designed for.
Okay. And you mentioned fire. Is there a specific fire suppression system that these have to use? Is it water?
Yes.
Is it foam?
It's mainly water.
Okay.
Yeah, they're mainly water systems.
And is there any risk of like a thermal runaway because we're dealing with batteries here?
So there's always risk of thermal runaway, and most of the testing that you would have on your system, propagation would be prevented. So in your electronics around the battery, if they detect heat or they detect a failure, they usually shut down that rack or drawer. And then there would be alarm or notification, and to repair that or replace that, they would come out and replace the whole entire rack.
Okay. And
Just on that end, we've got some other speakers who are going to speak more specifically to some of those concerns.
Okay. Thank you. And lastly, is there any concerns with noise levels with these facilities?
Not that I'm aware of.
Okay, that's great to hear. Thank you.
Great. I'm back. Becca Gillespie again, also Battery Innovation Center. So just to round out what Les was saying, what Chris was saying in the beginning as well. The market has been around for a while, so it's becoming somewhat stable. You know, lithium iron phosphate is becoming the commonly deployed. There's the modularization, the containerization, and the integrators are sort of consolidating around a certain business model, and the winners are winning and the losers have left the market. So the costs are getting pretty stable, as you can see. You can see here the average US cost turnkey price, which means, you know, you've not just manufactured the cells, but you've put them in the packs, you've put them in the racks, you put them in the container, you've built your fire suppression system, you've built all your temperature sensors, and you've actually deployed it to the field, is only $226 per kilowatt hour. So just call back to the fact that I said hour at the end there. So that's a per energy, and that's how costs are typically quoted, is $1 per either megawatt hour or kilowatt hour. So just if you ever do need to do those property assessments and whatnot, it does go by energy typically. And that's 236 per kilowatt hour, which is extremely low. And even the tariffs, and even the highest tariffs that have been presented are really not impacting that greatly. And go to the next slide, please. So I guess we were also asked to speak about some of the other BESS projects in Indiana that you might be interested in knowing about or seeing, or just knowing about their existence. These are all of the currently deployed BESS projects in Indiana. I even went on the EIA website just today, double check that nothing had been deployed in the last few months. So this is current as of August, the August EIA generator report inventory from the EIA. You can see that the original deployments were 20 megawatt hours, 20 megawatts and 20 megawatt hours down in AES, and that's a 1 hour battery, so those are pretty rare nowadays. And then they kind of started eking up. They had a 1 megawatt deployment in Southern Indiana. Duke did three 5 megawatt projects in a row. You can see those 3 5 megawatt projects they deployed. And then really just this last year, literally in 2025, is where the biggest projects started getting deployed. So NIPSCO, in partnership with NextEra is a development, NIPSCO's a utility, I'll get into those various players in a moment, deployed these 45 megawatt, 180 megawatt hour systems at Calvary Energy Center, and a 56 megawatt, a 225 megawatt hour in Dunn's Bridge 2. And then the biggest deployment was just in March of this year, and that's the Pike County Energy Storage Facility, co-located with a coal plant there in Pike County, and it's deployed by AES, and that is 200 megawatts and 877 megawatt hours. You'll notice that 4 hour rule is kind of applying, so that's good. But there's a lot more coming. This is really just the tip of the iceberg. You can see the same thing in PJM and MISO. The queues are huge. Lots of people are trying to deploy energy storage. So there's a big interest, and there's a big draw for battery energy storage. Here's just a few examples. Well, we'll speak to this one mostly because I just most recently, it's okay. We'll just jump to the Pike County BESS. I guess you can't really see the bottom picture, which is a construction picture, which I kind of like. But this is a 200 megawatt 4 hour system. So yeah, like 800 megawatt hours approximately. And you can see those tiny little containers all stacked up in a row. And honestly, you can't see them in the bottom there, but they're all stacked up in a row, and they're each connected to one PCS, all connected DC together and then turned into AC. And then all those little rows are connected together on the AC side and make up the entire power plant of 200 megawatts. So it's all very modular. There's DC modules, they connect to the PCS, and then each of those little things is an AC system that each of them is modular, which is really good for, if the failure were to happen on one particular line, whether it's the air conditioning going out or some sensor going awry, you really just lose one little module of your big system. And And that, yeah, again, that came online in March of 2025. Go ahead to the next slide, please. So yeah, just walking you through a little bit of the development process. What does it look like when a battery energy storage comes to your city? First of all, sorry, I forgot, I reorganized this. First of all, why would someone want a battery energy storage project? What are the main uses of battery energy storage and why are they valuable? So for in front of the meter systems, that means systems that are being sold to either used by a utility or sold in the wholesale market, like MISO or PJM. One of the biggest values is the capacity value. And the capacity value means that that battery energy storage system is there on the hottest day in July and is allowing you to not build, say, that next gas plant and to meet those peak loads. You can't see the little graph down below, but you've probably heard that PJM's capacity market went up like fourfold in 2025, 2026, and again, went up another 56% between 2020 this year. So those capacity prices are going up a lot, and there's nothing better to bring them down but to build more capacity. The second use you might do in front of the meter is energy arbitrage. Arbitrage is just simply buying low and selling high. That's just a fancy way of saying charging when there's too much solar or too much wind on the grid and the prices are either negative or really low, and discharging later when there's a peak. They can do other things on the grid. They can do frequency regulation. They can do transmission deferral. And I've even seen some cases where in front of the meter systems through a special tariff are used to support like a factory staying online, doing a behind the meter, typically a behind the meter application. I didn't put it in this list, but it can happen as well. But typically they're working in the wholesale market and they're making sure, the grid stays alive, your lights stay on. Behind the meter applications, that would be if a factory were to buy a battery energy storage system for their own use, for example. The main purpose of why a factory would find that economically beneficial is, as many of you know, factories pay something called a demand charge, which is a reflection of how much energy, the peak power that they consume during the month. And so the battery energy storage system can help them flatten their curve by discharging and meeting that demand. And so they don't have to pay as much in that demand charge. But then, of course, the beauty of battery energy storage, it can also be used to do power quality correction. So they can make sure they have really high power quality at their factory, good voltage support, all of those things. And then, of course, backup power. I won't go into all of those. Right, let's get to the next one. So that's why someone might be interested in building it. And the players that you'll meet along the way as this battery energy storage system is being deployed are shown here. Kind of early development phase, who would want to build a battery energy storage? Typically the person involved is just simply the developer. So the developer is looking for land. They're trying to get interconnection rights, trying to validate the business case, understand that battery energy storage is needed in this community. It's needed by the utility, or it's needed by the wholesale market, or it's needed by the company that's going to put it behind the meter. And that's called the off-taker. So they're trying to identify that off-taker, get the interconnection, and get the land rights. Late development, it's really, there's only so many smart art designs in PowerPoint, but it's really a blurry line between these first two. And I couldn't show that blurry line very well, but sometimes some of these things float between early and late development. But only in late development is where you start meeting the integrator. So that's going to be the person that's putting together the system. They'll start telling you which technology they're using, the chemistry they're using. And that's when you can meet the EPC firm. The EPC firm is the person who's going to actually build the system, move dirt, put the thing down. Between late development and construction, you have something called notice to proceed, or FID, financial investment decision point. And that is not a blurry line. That's usually a very bright line. And after that is when the construction can actually begin on the site. And that point, you should have mostly the same players that you had in the first two phases, although sometimes the whole project will change hands. So it's very typical that sometimes between early and late development, they might sell the project, and sometimes between late development and construction, the project might change hands. And then finally it goes into operations, and that's where you're using it to do the application that I just discussed on the last slide. Okay, last one, or not last one, this fourth section. So again, now you're in operations mode, and you might be wondering who are the key players in the operations mode. The battery energy storage system may have all of these people that are listed here, might just be one entity. And that would be typically if a utility were to own it. So those ones I was showing you earlier, where Duke just built and owned and operated and used all of the power, you wouldn't have 4 different players during operations. You would just have Duke. Now, one of those Duke systems is at the Camp Atterbury. It causes a microgrid. It helps them form a microgrid if there was some kind of a grid outage and the military installation needed to stay online. And so in that case, you would have almost all of these people would be the same, except one of your off-takers of your backup power would be Camp Atterbury, the actual military installation. So anyway, but in some cases, all of these people are different. So I'll talk as if that's the case. The owner would be the person who actually owns the battery energy storage system and will be financially liable for anything that were to go wrong there. And that would be the person you would most likely interact with as a city. The operator would be making the day-to-day decisions about when to charge and when to discharge. And on the wholesale market, they'd be trying to maximize their profits and follow the rules and then the off-taker could be a different person, and that could be the person actually buying some of the power. Although typically, you know, if you're operating and buying and selling on the wholesale market, the off-taker would just be buying the capacity rights. So that's the right to just say, I own a kilowatt and I can discharge that when I want it. And then finally, an O&M contract. Now, this is where you get really different from like a gas plant or a coal plant, because any coal or gas plant, if you've ever toured, they're always run and they're operated by the same utility. But even the operations and maintenance person works for the utility. Their email address is at aes.com or whatever their thing is. But in battery energy storage systems, a lot of times they do run them from a centralized location, and their O&M people come from the integrator that originally built the system. So a lot of that work continues to be contracted out. All right, and next slide. I won't go through each of these because I'm probably running out of time, but I think I kind of gave a lot of these examples before. But yeah, the most basic one is the utility owns it all. And the utility is the off-taker. And then the sort of second most basic situation is someone called an IPP, an independent power producer, owns it and operates it, and they sell the capacity rights to the utility, and they arbitrage in the market. And then the third most common would be a factory owns it and uses it for behind the meter applications. So probably should have put those all on one slide. We can skip through those 3. I guess any questions before I go into the benefits and the risks?
Any questions? Councilman Kurt?
Yes. If one of these battery storage plants came to Elkhart area, how much land would it take to build it?
That's a good question. I don't know if I know off the top of my head. It's pretty small. You could see the picture of the Pike County. That was 200 megawatts. I'd say that was about 5 or 6 acres for 200 megawatts. So it's pretty small, but it really is modular, and it really grows roughly linearly with the size of the battery, except that I think your model ordinance included setbacks. So it wouldn't be linear because you'd have your setbacks all around. And then after that, it would be roughly linear growth, depending on how big it is. But they're pretty small. Like say each of those, that was a 200 megawatt system. I'd say each of those was a couple megawatts. Usually each of those little strings is a couple megawatts. So I could look that up for you to make sure I know exactly the number, but off the top of my head, I don't know, sorry.
I was just wondering, what side of town would you put something like this on? And also with nuclear becoming more popular, you think some of these outages wouldn't be necessary anymore, wouldn't happen anymore? I know AEP has their Cook nuclear plant up in Bridgman.
And they've announced Rockport. I guess they're trying to turn their coal plant into an SMR.
And then Covert, they just brought a new nuclear plant back online.
Nuclear is an excellent baseload resource because it can be on all the time. It's so excellent at being on all the time. It actually has you don't even save a dime when you turn it down. So it actually likes running at 100% all the time, literally all the time, not just it can't, it's almost never turned down. So it's a great baseload resource. But when you want that flexibility, that hammering up and down to respond to load changes and renewable coming on and off, I think battery is still required for that. I mean, now I guess we use gas, so gas can also do that job. But the moving up and down, the ramping, I think there will still be need for ramping resources even after there's nuclear. But nuclear is a great constant on resource. It just provides that first chunk of our load curve.
Right.
Councilman Holtz?
I was just going to ask, and it may come up later, what would be the timeline? You had the different stages, you know, and you said may change hands between this stage and that stage.
Yeah.
So that slide, what would be the timelines for each stage if you think back to it?
That's a great question. Again, I would say it's very flexible and it changes a lot. And one of the big issues, I don't know how closely you followed PJM's interconnection queue issues, but unfortunately the queue has gotten so out of hand that projects are taking 5, 6, 7 years. That's part of the reason the capacity prices spiked. It's taking 5 or 6, 7 years to even get the rights to connect to the PJM grid. They're fixing it. So is MISO. Everybody's fixing it. And so it'll be on with a year later, but let's say that the world is perfect and there's no interconnection queue delays and it's 2028 and FERC, which has issued an order that they have to have it done by 2028. I would say the early development is roughly a year to infinity. Like if they can never secure the permits, then they can never secure the permits. The late development, the same, you know, you're trying to get your permits, you're trying to get everything in place, but if people really don't want it, then they don't want it, then that would be, again, infinity, but to roughly another maybe 6 months is the lowest that second phase of development can be. And again, with nuclear, that second phase is a lot longer, but with battery energy storage, these things are just, we know what they're going to look like. The financiers, the banks, you just show them the business case and they know how to sign off on it. All the due diligence is done. Everybody knows who's good and who's not. So that's about 6 months in a best case scenario. And then construction can be 1 year, really kind of short. And then the operations can come online. So it could be about 2 years total, which is lovely. I just wish, you know, the interconnection queue creates a really big error bar on that right now.
Thank you.
Yeah, it's a very fast resource. Yeah.
I wanted to go to a little bit more direct questioning because I feel we're going around some issues and we're missing the core issues, no pun intended.
Okay.
And that is, I just have basic questions. This is not my area at all. How long is storage capability for charge and the leak loss? Are there leak, power down, just loss of energy when it's not used? And is it always in charging mode? And then if it stopped, is there a leak process? Is there a, decharging, so to speak, that the batteries would just power down?
I can speak to aux loads because you do have to keep your AC on. Typically, you have to keep your So from the auxiliary loads perspective, you do have to have some sort of power typically, unless would be better to speak to how quickly the battery self-discharges on the DC side.
So normally you have these batteries always on the bus, so they're always connected to your system. Now, when they discharge and they need the power back up, over time, there is some self-discharge. And the LFP chemistry slowly discharge, it's less than 0.1% or so per year. It really just depends on your environmentals. So most of these are in air-conditioned units, so they keep them at temperature. So they kind of sit on the bus, and the self-discharge is not degrading. So when self-discharge usually happens is usually when the batteries are dormant, and the batteries will degrade over time. But because they're on your grid, they're always connected, so they'll always keep them up to a point where they're at that level. What they do to protect the batteries is the battery is derated somewhat, just like in your vehicle, it's derated. So it's usually operating in a capacity window. So there's top of charge is usually maybe 92 or 93% of what the battery's capacity is. So it never gets up to 100%, and they never discharge them down to maybe 15%. So that keeps them in a constant condition.
So what is trend of overpower, spikes, surges? What happens in those incidences? Does it come back towards the battery? Is
Nope.
there resistance on the line?
Yep. So in a overcharge or overpower means that something is dumping more power. The battery's at 100% capacity. We're at that 92%. And something is dumping charge continuously into the battery. That will overheat the battery and push it into what they call a thermal runaway. Now, what protects it from that? The electronics protects it from that. So your battery management system controls that current coming in. And when it reads that the battery is at that 92% or 100%, what we'll call, it will stop the charging. So that means you had a failure in the BMS. And usually that would happen. When that happens, the battery would shut off. So now you have almost triple circuit protection in your battery management system. So each drawer in that rack has what they call a battery management system. So it has an electronic card on it. So that electronic card is designed to control the system inside in that one rack. Then your rack has a card on it, and that particular card is designed to control all the modules in your rack. Then there's a main control unit that's designed to control all the racks, to make sure all the racks are. So you would have to have 3 failure points for you to go into a thermal runaway. So meaning that you would have to have your main control unit fail, you would have to have your rack control unit fail, and you would have to have your module drawer fail. So that's kind of redundancy of how they control it to keep it from going into a thermal runaway.
So then, again, I'm just trying to figure the flow of money, the benefit of the savings, and who actually benefits overall. So does that mean the utility supplier, it seems as though they are the greater benefactor? If utility, NIPSCO would set aside a program such as this, they would get paid for it. Their cost of building it is somewhat funded because they can move that on to the user. Is it the utility supplier? At what point does the consumer benefit, or is it primarily that it minimizes the loss of productivity because there's less brownout or something of that nature? Where is that savings to the consumer?
Yeah, because she has a whole slide on community benefits.
I was just going to go into community benefits, so it's a pretty good segue. Yeah, let me do it, and then I'll make sure I answer.
Very good.
Does that make
Thank
sense?
you.
Okay. So let's go. So the main community benefits, rate impacts should be lower rates, tax benefits, firm capacity, and grid stability and economic impact or development. I have to memorize those ones. I guess they're hidden behind my words there. There we go. Next one. I've already mentioned this. BESS is providing firm capacity to meet system peaks. Chris already mentioned AEP is expecting a lot of load to come online, expecting to double its peaks by 2030 to 8 gigawatts. And BESS can provide that capacity to meet those peaks. I think, at a high level, when you ask who's going to get that capacity, who will actually benefit from that capacity that comes online, it depends on who's buying the rights to use that capacity. I don't think right now, if AEP were to buy it, you couldn't necessarily dictate where they're going to use that capacity, where those rights will go. But I do know that if everybody says no to it, we're all not going to be able to do economic development. So I guess I can't say that for sure each yes to each new capacity asset will equal exactly the exact same capacity in your exact town, but I will say that we're very short of capacity in the whole grid. And so if we're all saying no to capacity, we will all have to say no to all the economic development opportunities. That's one. The other is you asked about the price, how it impacts it. BESS is the lowest cost right now of firm capacity. And so when a utility says to itself, I'm short on capacity, I need to go buy new capacity, they do oftentimes an all source RFP, which means they have to ask coal, they have to ask gas. Well, maybe coal, not so much in the past, but again, I guess there were some new executive orders today. They have to ask coal, they have to ask gas, they have to ask solar, they have to ask wind, who can provide this for me and who's the cheapest? And oftentimes BESS is the winner at providing firm capacity because it is the cheapest on a dollar per kilowatt scale. So I have here these little bars that just show how a 4-hour BESS would compare to a gas combined cycle. Now you might say to yourself, wait a minute, but that's not fair because combined cycle gas is actually generating energy and BESS is not generating energy. It's just buying and selling and arbitraging energy. It's just a peak shaving resource. And that's true. And so I show also PV plus storage, and you can see that's roughly comparable to gas combined cycle.
Sorry, what does PV stand for?
Oh, photovoltaic, sorry, solar. Yeah.
Thank you.
And so, I mean, like each of these utilities goes through something called an integrated resource plan, and they have to figure out what is the cheapest and lowest cost way for them to serve their load. They can say, I need this much actual generation capacity, I need this much like just firm capacity, which is capacity coming online. And they have to go through this whole process to find the cheapest way to serve their load. And by allowing them to include BESS in that portfolio, that should help them find a lower cost. They shouldn't be allowed to choose it if it's not the lowest cost solution. That's what the process called CPCN, or Certificate of Public Need and Convenience, which they go through with the IURC, the Indiana Utility Regulatory Commission, should find that they have gone through that process. They've made sure it's the cheapest resource that serves the need that they have. And that is the best for the ratepayers. That's what the IRP and the CPCN are all about. You're just saying we accept that BESS could be the answer. And yeah, here I'm saying, yeah, it's great, but it's not a generator. You could go back and forth all day and try to figure out exactly what it is that AEP needs, but they should know what they need. And in this particular graph, BESS is the best. In other graphs, it's not going to be the best. But if you're just looking for capacity, which is sometimes what you need, it is the best. And we kind of need it right now. So it's often coming out as the lowest cost resource. Does that kind of answer? Not really.
I find that it's a moving target. And if we knew the trajectory of sodium, for example, or any of those things, you would say, oh, let's wait a moment and put the right thing forward. We don't have that crystal ball. I don't understand that part, but it seems as though the undertow of this is there is sort of a plan, which means there's got to be somewhat of a site, and you're here for a reason. And that's what I really want to get down to. What would be the city involvement? The nonprofit status, so no matter where this is built and its risk and so on, it doesn't pay property taxes back, so it's got to generate a benefit to someone. And so that was more about what I was gearing towards. Is it that the utility is expected to have ownership? Do you own any of the sites, or you just manufacture what's at the sites?
Councilman Henke, I think this is just for a general UDO discussion of it and not a specific thing, to my understanding right now. I understand that discussion might be coming in the future at some point,
Yeah,
but this is just about the.
It just means we're dancing around what should be a
So Councilman Hickey,
conversation.
the subject matter experts that are here tonight are not affiliated directly with any utility or any projects. They're with the Battery Innovation Center, and they're here helping us understand the differences and how the projects work.
I appreciate that. It is a money flow issue, because ultimately, if it's coming to your community, and if you would look at FEMA and if you'd look at the Utility Regulatory Commission and they're standing on such issues, there's got to be, there's a pretty known risk. There's got to be a pretty known benefit. And then the question is who all benefits?
And so that kind of brings me to this slide about tax benefits, but I also want to do this with a heavy disclaimer that we are battery experts and I am not a tax advisor, nor am I a tax lawyer. I think it would make sense to talk about tax benefits, but I do want to have that heavy disclaimer right up front. I'm not your tax advisor or attorney. So, nor am I anybody's, nor do I even like paying taxes all that much. So according to the IOD, the Indiana Office of Energy Development, they released a study on battery energy storage in 2025. So this, I think, in June. The battery energy storage technology is a business personal property. So whatever the taxes that your town has on business personal property would apply to battery energy storage equipment. Again, I would make sure, if you have auditors involved in this, they should be multiplying the $236 or whatever that cost is that they think that the value of the battery energy storage is, multiplied out by the energy capacity, again, hours, make sure hours is in there. And that would be about how much of a value that business personal property would be worth. So I think the example system I was giving before was talking about 40 megawatt hours, just 10 times 4 is 40. That's why I picked it. Very simple. And that would be around $9.4 million worth of business personal property. Again, I do understand that SB1 made that so that could depreciate over 5 years. So you have to get all your value out of it in the first 5 years, and it can depreciate down to $0. And I think I understand that there's an exemption of the first 2 million. So I don't know what your rates are on top of that. Again, I'm not your tax attorney, but that would be ultimately, it's a business personal property and it's worth about that much. And kind of the last 2 bullets are the math that I think you would have to do on your own side. But it's about a 40 megawatt hour system would be $10 million of business personal property. So whatever that means for your town would be your tax benefits.
Thank you. Just a quick question. You mentioned the IURC. What are the regulatory commissions that are involved in the creation and the ongoing existence of one of these facilities?
So IDEM has jurisdiction.
IDEM?
They do look over the environmental implications as well as the decommissioning. They have a decommissioning standard they have to meet. IURC, obviously, as well. And then the Indiana Department of Homeland Security, I will leave mostly to the following speaker because that's the people that implement the fire safety standards, the NFPA 855, which is the way to keep them safe.
Thank you.
I mean, and then of course FERC and NERC and all the people that keep the electrical grid stable. And MISO or PJM in your case, and AEP as well. So the other benefit that might be local is the economic impact. They do create some jobs. Here's some job numbers, though they are kind of meshed together, so it's hard to tell which of the jobs were associated with PV and which were associated with storage. So I just quoted them straight from the press release. So you can see the Dunsbridge Energy Center, which had both PV and storage, created up to 300 jobs during construction. That's from their press release. And they estimated 59 million in county tax revenue. That's a bigger system than I've been talking about. I've been talking about a 40 megawatt hour system notionally, but that would be a bigger system. And then there's 2 projects in AES Pike County. One that I showed you the picture of, the Pike Energy Center. They're also building another one that has solar and storage. There was a little typo in their press release. They have 180 megawatt hours of storage. It's actually way more than that. As I told you before, it was 800 plus another 180 because of the 2 systems. But I know that the total jobs impact was on both projects, so I can cite that here. And that was 300 jobs during construction for those 2 projects. And then, but then that particular 200 megawatt system created 2 jobs on an ongoing basis. So I guess that's a little bit smaller than some of the coal plant implications, for example, and nuclear. And then they're also creating $40 million in taxes and benefits to Pike County. The other local benefits are whether it can support a distribution grid. And so if the utility is the owner, they can use it to support the distribution grid as well, which for a long feeder that's overloaded can provide the voltage support to make sure you don't have brownouts at a manufacturing facility, for example. Again, that depends on the owner and it depends on them actually using it to do that. It can also support the transmission center system. Again, if it's owned by a transmission owner and they're using it for that, it can defer major upgrades to a transmission system. And then I'll go to the next slide. There's something called electrical stability, which probably this is a lot of information and most of it's really not relevant to Indiana. But essentially, when we started putting all this PV on the grid in California and Texas and Spain, as many of you know, there weren't a lot of rules around what the voltage range the inverters had to be set for to be stable. And so they tended to trip off whenever the voltage went low. That causes instability because, a generator would go down and the voltage would drop just a little, and then all the PV systems would be like, whoops, I see that going down, and they would shut off. So Spain had a big blackout this summer that was possibly linked to that. California and Texas have each had little mini ones that never got that bad, and NERC stopped that. They've stopped that code. It will not ever apply to Indiana because they have made the voltage range of these inverters, they have to either be IEEE 1547 compliant, and you guys, because you're in AEP territory, every battery energy storage system that's behind the meter will have to be IEEE 1547, or if it's in front of the meter, it's IEEE 2800 compliant. And because of that, you also will have that because PJM enforces IEEE 2800 starting in 2026, next year. Yeah. So you're in luck. It's good. There will never be instability caused by battery energy storage. And what's really awesome is battery energy storage can actually cause stability because it can start discharging when there's a moment of instability. And that won't happen until 2027 or 2028, but PJM is on it, MISO is on it, and MISO is actually gonna get it done faster, but PJM will be doing it really quickly. That will keep the lights on and keep everyone from having any instability. Quickly, I'll run through the risk and risk management here. Let's go to the next slide, please. So yeah, ITEM, I already mentioned, ITEM has oversight of environmental concerns, but for local ordinances, you can oversee those and have additional requirements around decommissioning. And your local ordinances can do setbacks and visual and auditory rules as well, which I read the local ordinance that you proposed that seemed to have many of those things as well, making sure there's no noise generated by the air conditioner or whatever. From a fire risk perspective, the best regulation out there, and I won't belabor this because we have someone else speaking on it, is NFPA 855. And actually, Indiana already has that rule statewide that everyone has to comply with NFPA 855, and it's implemented and enforced by the Department of Homeland Security of Indiana. And then grid stability is overseen by NERC. So those are kind of the problems you could have, and here's how they're being addressed today. So I'm probably running way out of time, sorry. Okay, and so then I think that's pretty much it. I guess another major risk that people like to talk about is battery energy storage fires. And there's really two major fires that happened in the last year. And those both happened using designs that were designed and built before NFPA 855 was implemented. They both were not containerized systems. So the trend towards containerization, which has happened for economic reasons, is vastly improved the safety of these because each, like I said, each modular container is its own element and it can't spread from one to the next. And finally, the trend towards LFP, which we already talked about, lithium iron phosphate, has made them vastly safer. And those were before that trend had happened because people were just basically putting car batteries in an old gas plant. So sometimes people see those in the news and they get very concerned. But I'd say that the new regulations under NFPA 855, the trend towards containerization, and the trend towards LFP have all mitigated those. Sorry, NFPA 855.
Yeah. Okay.
Sorry, but I shouldn't belabor that one. I just wanted to talk through the risks quickly, and maybe we'll let the expert on NFPA 855 talk more to that too.
Any questions? Councilman Hickey?
I'm, again, trying to get an understanding here, but these are built-in modular components. The modular components, therefore, if they're going to be contained of any spill, any gas, any fire, fires are said to be between 900 and 1500 degrees. So are the modulars capable of maintaining that heat? How do they manage that? Since the cell breakdown is going to produce its own oxygen, therefore it's not going to burn out. You can add all the water you want, but at what point is it self-contained?
Yeah, so it's, I mean, I probably, again, should leave this to one of these two, but so I worked on 855 just for a little bit, so I do know that it is physical metal barriers as well as actual space. So at some point, at that point, they've said this is literally how hot it could get. I should hand it to the next person, but it's actual physical space so that they're far enough apart that you really can't radiate at that rate. Maybe I'll let him speak to that as well. Yeah.
Real quick, what about water usage concerns? How much water these modules use or a site? Or is that?
I think they're all closed loop. No, we can talk to that as well.
You mean for cooling or,
Yeah.
okay.
Yeah, every system I've ever seen has been closed loop. Like there's not, it does use some water to get started, but it won't use water over the long term and could be cooled over with a closed loop and isn't doing what you would call once through cooling, where you pull in water and you heat it up and then you push it back to the river.
Okay,
But,
thank you.
all right, thank you. All right, thank you guys, and I'll hand it off to Ian.
You're talking a lot. Evening. How are you guys?
Okay.
This is something I'm never going to get used to. So it doesn't matter how long I do this, this is still going to really weird me out. My name is Eric Wood. I'm a senior consultant with Energy Safety Response Group. Prior to coming over to ESRG, I was a professional firefighter in the state of Ohio for 20 years. The last 6 years that I was in the fire service, I had the opportunity to be a part of ESRG's testing lab that we also have in the state of Ohio. In that testing lab, in that capacity that I was operating on the last 6 years, I was looking at destructive testing that we would do from a firefighter's perspective, right? That was my viewpoint. That was my lens that was provided to me while I was on that lab site. If you go to the next slide for me, that'd be great. I appreciate it. Thank you. So at our lab, what we've done thus far is we've had well over 300 medium and large scale destructive tests. So when we look at the medium to large scale tests, we're talking, as they referenced earlier, we're talking about anywhere from the cell to the module to the racking system, all the way to the full-fledged enclosures. We would do outdoor containerized events that we would do destructive testing on, and then we would do indoor isolated events where we would do destructive testing on as well, and then we would collect data. So it's our research and development phase, right? So we look at all these different parameters, all these different applications that we have to focus on as it pertains to NFPA 55, as well as UL 9540 and UL 9540A. Aside from the testing portion of it, and with me being a senior consultant, our company is kind of strewn about across the United States. I currently reside in the state of Ohio. Please don't hold that against me. But a portion of our company is in the state of Ohio. We have a portion of our company in New York, and then we have another portion of our company that is out west in Arizona. But we travel. That's kind of the main stick of what we do. We get the opportunity to come around and talk with folks like you. With our company, though, we're all firefighters. We all have some semblance of background in the fire service in some capacity, whether it was just line firefighting, or we were AHJs at some point in the fire realm, or we were fire engineers. I am not an engineer, so please, again, just a regular fireman moving over into the private sector. But our engineers were comprised of different departments like Boston, FDNY, those kind of large jurisdictions. And then the other side that we do, aside from the testing and the consulting, is we help with permitting processes, and we also help with the decommissioning plans as well. So there's a lot of things we do. We're one of the few companies that we can say that we work from cradle to grave when we work with different companies in the implementation and integration of these systems and sites. Next slide, please. So just to kind of give a brief overview, I know we kind of talked a little bit about different standards, different codes and all that, but I'm going to touch it at a high level and then I'll open it up for questions so we can dive a little bit deeper. But basically NFPA 55, that's the overarching umbrella as it pertains to battery energy storage systems. Basically, it looks at companies and they say, okay, we're going to take you from the beginning and then we're going to walk you all the way to the very end on the decommissioning side of it and how the decommissioning plans should look, right? So part of that 855 though means that you have to have some people that oversee it. They oversee with the authorship of it, how it writes, how it looks, and then how it applies when these systems go to be integrated in. So part of my company, 4 to 5, it's 5 now, I think we just had our 5th one join, but they sit on the 855 committee. They actually sit and they help author that specific NFPA code and how that correlates out then to battery energy systems. And I know I referenced UL 9540 and 9540A, but those are 2 testing things that we have to look at. So UL 9540A in essence is a propagation test. So with that propagation test, kind of again, what they were talking to earlier is we look at the cell, module, the rack, and then large scale fire test. And then we do the UL 9540A test to determine propagation. So what that means is, and I'm sorry, that's really like, apologize. So what that means is that when I take all these cells and I put them into a module, I want to see, do I have outward propagation outside of that module? If I don't, then that means that we have a very good system put into place. But if I start getting that outward propagation, then all of a sudden, okay, well, now we need to figure out how bad is that propagation. So then we take that module and we say, okay, now we're going to put this module with all those cells. Now we're going to put it into that racking system. And now we want to see, do we have vertical? Do we have horizontal? What does that look like? And if we do see that outward propagation, but it doesn't go from one module to another, but it just stays directly correlated to that specific module, then that means, hey, this system's doing exactly what it was set forth to do. But then we also want to see, well, now we want to ramp it up a little bit more. Now we're going to take all these racks and we're going to put them into this big enclosure. And now we want to see, what does that look like? What does that propagation test look like? And again, with that UL 9540A, it's not a pass-fail test. So please keep that in mind. It is strictly just that, a propagation test. So when we look at the propagation test, though, as he alluded to earlier, where there's different safety mechanisms that are integrated into place, under that UL 9540A, we don't put those safety mechanisms in. We actually have to take all those safety mechanisms out, and we actually take the batteries and we charge them up and then we fail them. Because again, we want to see, what does that failure look like if all the safety mechanisms are not integrated and secured in place. Does that make sense so far for everybody? So then, it's a lot, and I apologize. But then we look at the UL 9540. So the difference with that one now is now we look at all the safety mechanisms that pertain to that specific technology. And then we test that. And then we want to see that when we initiate a thermal event on the testing and research development side, do those safety mechanisms do exactly what they're set forth to do? Do they operate correctly? Do they obtain what we want them to obtain? And then that is how these systems then get put into play. So any system, technology, what have you, that looks to be implemented and integrated into a specific site, they have to meet EPA 55 and they have to meet UL testing standards as it pertains to UL 9540 and 9540A. The other thing that these things have to abide by is known as the International Fire Code. I had an immediate discussion when you first arrived, right? But you have a division chief here that's part of the fire marshal's office. Now, one of the things that I did not like doing when I was in the fire service was reading code. I just enjoyed writing the engine. I didn't really enjoy writing the medic. So when it came to code, that really wasn't my thing. I didn't like doing that. But when I transitioned out into my job now, they're like, hey, buddy, you got to read code. So now this is the new realm that I'm in. But again, when you start looking at the code and then how it works, not only on the 855, but then you start looking at the testing standard as how that UL is applied to these specific technologies and integrations, you start recognizing that over the last so many years, and remind you, I started doing this back in 2017, 2018. Now we're getting to the point where that propagation, we're having a very difficult time getting propagation when we look at these tests. And it's not just our lab, it's their lab as well. And there's other nationally recognized testing labs across the country that are doing the same test. And we're not getting that outward propagation. So when we look at that UL 9540A application side of it and trying to force that thermal event to actually get to the point where we can say, yeah, we're getting the failure, it's actually very difficult now for us to obtain that failure. And it's because of the technology and the chemistries that a bunch of different technologies and companies are bringing forward. So this is just a few of the things that they have to abide by as they look to bring these systems into play. So when you start getting a permitting process that comes to you, right, these are all the things that they already have to do behind this. They have to correlate and say, yes, this technology, this system meets NFPA 55. It meets all the UL testing standards. This isn't just like wet spaghetti we throw at the wall and see what sticks. This is legitimate testing. It's heavily focused on when it comes to the safety standards as it pertains to battery storage systems. If you'll go to the next slide, please, I'd appreciate it. So with 855, one of the things that we look at is it's a constant cycle that this thing has to go through. So it's not just a one and done, but we're always evaluating, looking at it. So the new iteration of 855 just dropped for 2026. Prior to that, it was 2023. And then by 2029, they'll do another iteration, so forth and so on. That's the great grandiose thing about NFPA 855 is it's constantly on a cycle to reevaluate all the different things that are out there as it pertains to the National Fire Protection Association. And then we start looking at a hierarchy of those codes and standards and then how those things are laid out. So again, 855 is going to be the overarching standard that these systems have to abide by. And then you start facilitating out, like I said, the UL 9540, UL 9540A test and how those apply to NFPA 855. And then there's a whole slew of other things like NFPA 72, NFPA 70, NFPA 68, NFPA 69, all these different parameters and all these different testing standards that we have to focus on, that these systems and sites have to focus on for safety. Again, safety is the key paramount thing here that these systems are looking at and these integrators are wanting to bring forward. I think I have one more. I might be wrong. I do. Awesome. So just to kind of give you an idea, and I don't know how well you're going to be able to see it, but just to give you an idea of what all we sit on. So we do sit on all the different UL standards for 73, 1974, 1989. There's a few more that are underneath that you might not be able to see. We also sit on the 855 committee. We are also very heavily involved in NYSERDA and how NYSERDA plays out in the state of New York. We also helped author NYSERDA and then how that then gets played not only in New York City, but just across the state as well. And then we do have knowledge and experience with older related codes and then how those then get applied. So that's kind of my thing in a nutshell. And I'm here to answer any questions if you guys have any.
Councilman Crabtree.
These safety mechanisms that you mentioned, can they prevent a thermal runaway?
Yeah, so the concept behind this is as much as like what he talked with the battery management system. So we all have one of these. Everybody carries them around. Kids have them nowadays, right? You can't get rid of them. But if you remember back in like 2010, 2011, when all these things were blowing up in people's pockets, everybody remember those? Yeah. Right? It's because it didn't have a battery management system. So you basically have your own personal battery management system integrated into your cell phone. So the really cool thing with that is it prevents overcharge of the phone. That's what was happening back in 2010, 2011. So they would sit and they would charge it and you set it on that charger and it would just go, 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 go. And then that battery cell in there would expand and expand, expand to the point where it goes, I can't do this anymore. And then you have the failure. So with the battery management system now it's in your phone, when you put it on the charger, if you ever get up at 3 or 4 o'clock in the morning and you ever look at your phone, it'll tell you on there that it's smart charging. And it won't be done charging till 3, 4, 5, whatever time in the morning. And it does it on purpose because that battery management system is preventing that overcharge. Now, this is on a very, very small scale. But the battery management system that's integrated into these systems is a very robust battery management system that is in. The ideology behind that battery management system is just that. It is the state of health of the battery. It looks at the state of health, the state of charge, much like what he talked about earlier. It's a very pertinent thing that's integrated into these systems because it's giving real-time data acquisition, reading down to the nth cell that's in there. And then the site is monitored 24/7, 365. So they can verify exactly what's going on at that given moment. So if they start seeing something outside that parameter that they don't like, they can go in and they can go, don't like it, shut it down. That's one of the first things that's in. Then there's other things other redundant systems that are in play, thermal management systems, right? Because these things like to have that homeostasis. So they always want to maintain the thermal capacity over their life expectancy. So again, it's just those things that keep them thermoregulated 24/7, 365. But when we look at that battery management system itself, from a firefighting standpoint, that is a huge to-do for us. Most of what we do on a day-to-day basis in the fire service is we're working behind the 8 ball. We get a call for whatever, and then we roll out the door. And then we have to go based on what dispatch gave us. And then we usually don't make an incident action plan, and correct me if I'm wrong, Chief, but not until we get on scene. Because now we're getting that visual acuity of what's currently happening directly in front of us. With this battery management system, what it does for the fire service is that if they were to have an alarm at a site, they make a phone call. because they'll have a site-specific emergency response plan planned out for them. They'll have a document that has all the new numbers that's verified for them. They make the phone call and they say, hey, we're getting an alarm at this site. Can you tell me what's going on? And they can get real-time data acquisition on that specific site and what's currently happening. That's one of the great things about the battery management system. But yes, it does have the capability to then start shutting that system down before it even reaches.
So it would be
thermal runaway.
preventable. It would be preventable.
It is preventable, yes. That's a long-winded question. Sorry, I get a little.
No, that's fine.
So to be clear, your role and responsibility was to try to make bad things happen in order to prevent them from happening in the real world by running through all these real world tests, utilizing the NFPA 855 standards, the IFC 1206 or something like that. And since 2016, you've gone from it being pretty easy to do that to having much more of a challenge, but you're also testing the different types of battery that was mentioned earlier.
So the ones that we're looking at that we've tested have been NMC, the nickel manganese cobalt, and the LFP, the lithium iron phosphate. Right now, we've not had the opportunity to do the sodium portion. I know that some of my cadre that's out there, because again, we would fluctuate that we were on site. They would also have the opportunity to test a small share of the other type of chemistries that are out there. But what we've seen, and much like what he spoke to, the bulk of what we've dealt with throughout the industry is NMC and LFP. NMC was kind of the previous stuff that we dealt with because that was the emerging technology at that time. And then the industry said, we need to shift gears. And shifting those gears then led them to the LFP. And that's been the bulk of the industry, much like what she talked about earlier. That's the majority of what we've been seeing on the testing ground right now.
Okay, thank you. Speaking about fire response, what kind of potential environmental injuries could come from these fires in terms of fumes, carcinogens, things like that, not only to first responders, but those in the immediate area as well?
That's always a really good question. So part of our lab that we have to do when we do our interior testing, we've got a hood system that then collects all that off gas when we force it into that thermal event, so we can get that real-time data as what that off gas looks like. What we found over all the years of doing these destructive tests is the off gas is no more or no worse than what we see with a residential structure fire. Quite frankly, most of what we're seeing are things like hydrogen, hydrocarbons, CO, CO2. Those are mainly the four big things that we're seeing on a consistent basis. So when we talk about what are the negative impacts, we're not seeing any massive negative impacts to the outer area around that specific site. Within our own ERP that we write out, so again, that site-specific emergency response plan, we don't have anything in there that's built out to say that there should be an evacuation of any kind.
Okay.
But that's our take.
And that's just with the battery types that you guys have?
Correct.
Okay.
That's with both NMC and LFP that we've looked at.
Okay, thank you. Councilman Henke?
Let me make sure I understand. So you've done a lot of research, testing, simulations, but not on sodium? Is that what you said?
Not yet, no.
Okay.
Not done sodium yet, no.
Okay, and then there's,
Oh, sorry, could you please speak a little closer to
I
the mic?
apologize. No, we've not done sodium
okay.
yet, no.
And then one of the slides had UL 5800 is under development. Is that what the slide said?
That one's a little outdated. It's just something that we still have in there. As far as that one goes, I can't answer that one because I'm unsure where that one sits at this moment.
Okay, because that one had to do mainly with storage, which tells me that's still a work in progress based on incidents, experience. That's what that would tell me. And by the way, Brent, this goes in the 5th district. I'm just letting you know.
Is that right?
Yeah. So that's what I'm after realistically, because cobalt seems to be a less steady. Personal opinion, I'm not a chemist. Sodium, the sodium breakdown, it seems as though, and again, just for fun, that someone would put something back into the sodium so it goes either back to its original or, I mean, it seems like the extinguishing system should be another chemical as a neutralizing agent. I'm not sure what that would really do. Water and H2O, H2O2, what all do we get out of that? I'm not sure. I'm not going to do that. But mine was generally I know there's safety involved. I know there's risk involved. I know there's time involved. And I have to find a way that there's a measure of benefit involved. So thank you for your presentation.
Thank you. Appreciate it.
Councilman Crabtree?
I don't know if you can speak to this, but can you talk about any of the cybersecurity risk to this?
I cannot.
Okay.
That would be more on the backside. I'm just the fire safety guy.
Got it. Okay, thank you.
Real quick, what about potential for ground contamination after a fire, things like that?
Yeah, that's also a really good question. So again, part of the research and development that we do is we forcefully put water on because we want to see what does that water look like. So what we found over the years of doing this is that no water is best. Now, why do I say that? Every water that we put on there, we've collected. And out of that water that we collect, we have it shipped off to a third-party company that evaluates that water under RCRA, so Regional Conservation and Recovery Act. They look at hazardous waste disposal. Under that hazardous waste disposal, every ounce of water that we use came back no worse than wastewater. Now, the reason why we say we don't want water on it is because we don't want to prolong the event. We allow the enclosure to self-consume because it's what it's set forth to do. If we actually apply water to it, we're actually going to prolong the event even more so than what's already happening. That's the reason why we don't put water on. So what we teach the fire service is we want to do defensive operations. And the fire service understands what those defensive operations are, especially when we do our Battery 101 presentation. We come out and provide that Battery 101 education to local fire departments. And I've had the opportunity to do that, not only here in the States, but into Canada and Mexico as well. So again, I just want to make sure that I clarify. The water runoff will have no negative impact on anything, even if water is applied to it, but we just don't want them to put water on it because we don't want to prolong the event even more than what's already going to be in front of them.
I'm not a firefighter in any way, but I know in aviation fires, water is not applied. They use a special kind of foam.
Yep.
Is that something that's ever used?
So we've looked at different styles of foam. We've tried to look at like Class A and a handful of different ones that are out there. And what we found is actually foam makes it worse. So we found that water is the best applicator for it. But again, we don't want to put water.
Thank you. Any other questions? Councilman Crabtree?
You said not to prolong the fire, let it burn out. What gases are going to be released?
So again, a lot of what we see are things like hydrogen, hydrocarbons, carbon monoxide, and CO2.
Any other questions? Okay. Thank you very much, sir.
Yep. No?
Thanks.
Okay.
Good evening, Eric Trotter with the Planning Department. I've got Cynthia Bowen online, our land use consultant, and our project manager helping us with the UDO update. We're here this evening to kind of share where we are with our text that we're adding for the battery storage systems. Going to talk basically in three parts this evening. Number one, the UDO and the best standards that we've kind of drafted into the ordinance right now. Number two, our use conditions. And then finally, our plans, excuse me, certifications and insurance requirements as a part of our ordinance update language. As planners, it's our job to mitigate impacts from land uses, and that's why we've developed the standards that we're going to work over this evening. We have placed the BESS in the manufacturing district as a special exception. It would be a two-step process with Plan Commission and the Board of Zoning Appeals hearing the request as a final public hearing. The use conditions, we're looking at electrical, height, setbacks, aesthetics, landscape, fencing, noise levels, signage, and use of public roads. Next slide. And the use conditions specifically are the electrical components in our draft language currently to conform to all local, state, and national codes and national and international standards. Height not to exceed 30 feet above ground level, setbacks 500 feet from the nearest non-participating property parcel in line with best edge, and 200 feet from the nearest edge of best components, excuse me, to nearest edge of public right-of-way. Aesthetics and lighting, utility lines buried underground, and a lighting shield to downcast lights so it does not spill onto adjacent parcels. And vegetation should be cleared around the facility to protect from fire. Landscape and buffering standards should be consistent with our proposed section 884 outside security fence to the facility. And the facility should have a buffer area of up to 30 feet with a potential berm, fence, and landscaping per our section in the new UDO. Fencing and security between 6 and not more than 25 feet, no barbed wire fencing, and all access gates numbered, and locked gates will have a Knox box. Noise levels, a complete noise analysis, and use qualified professional to ensure that compliance with all applicable state laws and City of Elkhart noise ordinance, as well as any other requirements placed by the Board of Zoning Appeals. Signage compliant with ANSI 235, the American National Standards Institute specifications for accident prevention with contact and emergency shutoff information, including no trespassing, danger, and high voltage signage, and a use of public roads, road user agreement with the City Board of Works regarding impacts to right-of-way and mitigation of any of those impacts. And then Cynthia will speak on the next slide.
Thank you, Eric. So my name is Cynthia Bowen. I am, as Eric said, the project manager from Rundell, Arnsberger and Associates. So a few other additional things that we've included in this draft ordinance is number one, that the petitioner would have to put together an emergency fire safety plan so that they would work with Elkhart County Emergency Management Association and the Elkhart Fire Department, looking at what kind of specialized training or equipment might need to be provided, making sure that we have Knox boxes at all locked entrances, and having signs around the facility that have who the electric provider is, the site operator, the address of the facility, as well as GPS coordinates. But, getting that plan pulled together and making sure that everybody is on the same page and having that approved as part of the special exception. The second one being a decommissioning plan, and this would be approved by the council, but putting together a detailed cost estimate of this decommissioning plan by a professional engineer or a contractor who has experience with BESS. We want to make sure then that there's a performance bond or other approved method used in the amount of 125% of the cost estimate. And like we've seen in other things in solar facilities, we want this to be updated every 5 years, about 1 year prior to the lease end. And that if it's been active for 12 months, then it should be removed within 12 months at the owner's expense, and the property should be graded or reseeded back to what it was prior to becoming a battery facility. We also include a maintenance plan. So every year before the anniversary of that special exception, we want the operator to provide an operation and maintenance report talking about some of the repairs that they've had to do, maintenance or modifications that they've had to make at the facility, any sort of notifications, calls for emergency services, or any notifications from surrounding property owners. And a failure to not provide this would be considered a violation of the UDO. In terms of our design safety certification, we would want to make sure that here we are, again, relying on the NFPA 855 standards, that they attain all of the necessary approvals from the Indiana Department of Homeland Security, that they're conforming with all the applicable industry standards, as Eric had said, the American National Standards Institute. And these would all be part of the approval of the special exception. And then finally, insurance, that they need to maintain comprehensive general liability insurance in $2 million per occurrence and $5 million in aggregate, and that the city of Elkhart needs to be named as the additional assured, and that they would provide proof of that insurance to the planning department prior to any permits being permitted. And then failure to maintain that insurance would be a reason for cancellation of that special exception. And that we recommend that the Common Council review that coverage every 5 years as those rates do change as the facility and equipment change. And so those are the provisions right now that we have in this draft ordinance. And so I think we'll open it up for questions for Eric and I.
If I could, Eric, quick question. I noticed on there that it stated no barbed wire fencing. Our current substations around and electrical infrastructure in the city allowed to have barbed wire around them due to security concerns and things like that?
Yes, these regulations were to have the facility look a little less institutional or correctional.
I understand that. However, in just looking at recent events, there's been a number of substations that have been sabotaged around the United States. So maybe allowing them to have that security method in place should be considered.
Understood.
Councilman Henke.
So I guess a setback is one thing. And again, the greater distance, all the different articles talk about the greatest of distance. Thermal runaway, when one fails, there's a chain reaction thereafter. We talked about flooding them with water, and then the latest is to let them burn out. It's a matter of what does the public do at that point. And I think there was an article by a man named Trudeau, and he has been a 30-year veteran in this field. And he said it's not a matter of the if, it's the when, that fires will occur. He said, but the fire is not the bad part, it's the explosion. And he said there's nothing greater as an explosion. So then it comes down to me as the proximity to other areas, residential or commercial for all I care. You know, how far is far enough? In EV fires, 24% have been, you know, these types of batteries. 24% of all those fires. There have been 70 recorded fires since 2018. The only downside to that is it doesn't tell us how many total plants equals how many total fires. That would be the better number to have reported. Then it comes down to the other question that I wish I would have asked earlier as well. Are there manual overrides? And the answer that I heard earlier was yes, but it didn't say whether they were on-site or off-site manual people. Is there a person overseeing the process on-site 24 hours a day? Is it necessary, or is it just being monitored from afar, secondary to the automated cards that are in each system? And that would be a good answer to have as well. It's a lot to digest. I think we have some real research to do, but I feel as though this is a preamble to what's already having a greater discussion, and we're not on that discussion yet. So I don't know how to gauge this until we look at other data. And data by trend and history is the only thing we can look at.
Eric, real quick. Oops. Is there any discussion in the UDO about language for renewable energy, such as solar or wind on manufacturing sites or anything like that in the UDO? Is any language related to?
We have inserted some use standards Not that we have, so we are prepared in the event that we would have something. We were trying to look at emerging technologies and include some of that in there, yes.
Okay, thank you. Any other questions at this time? Mike, did you have anything?
I'll be quick. Appreciate all of your time this evening and your patience in going through this. You're right. Absolutely. We don't have any projects here. I think as we anticipate or we would receive projects, there are a number of those kinds of things we need specific answers to related to specific projects, how we do that. Hopefully tonight's session was informational, which is what we intended it to be. And you all raised a number of really good questions, and we will definitely be considering those as we move forward. Thank you.
I stopped hearing you after you said I was right. I couldn't hear anything after.
All right. Any other questions at this time by anyone? All right, seeing no other questions and being that we have no other matters to discuss in this committee, I will find us adjourned. Thank you.